the semiconductor fabrication technology. I'm a student Han. Okay, this time we're gonna talk about the lithography. First of the clean room. The clean room is cleaning room. If there is a such a other particle, what we don't want it is no allowed. So we use the clean room and we have to when we control and magnify and make it our semiconductor. So semiconductor is a small level. So simple particle is normally their size is micro size. It influences much a lot of damage and other we can control it situation happening. So we can prevent it. We have to we use the clean room to prevent this situation. And secondly, there is a force B and foob. The force B and foob is some carrier of the vapor, and what we use this. Why we are using this? Because of the human carrying this vapor, it is have some unexpected situation happening and vapors break down. This is so much loss of the financial and time, other resources. So we have to prevent this situation. So we use the OHP. OHP is, you can see the red circle. This picture is mean an overhead transport machine. So both P and F is carried by this OHP and go to the next step equipment. And these are clean room gearment. This is how we wearing in the clean room. And this is the real lithography. So let's get started. Okay, there is a full step of the lithography. It's first of all coating. Coating means this is the semiconductor sub, and we can lay the one layer upper the semiconductor. This is called the resist. Resist have a different name for what this relating with. We can use the photo, so we can call this resist is PR. And second step is exposure. Litho is using the light. We can exposure the light to the semiconductor and we can make it semiconductor what we wanted and planning. There is two type of the PR. First of all is a positive, second of all is negative. Positive is we make a layer, PR layer, and there is expose the light through the mask. Mask is other time. Okay, we can talk about. And with the light is through the PR, it make this. Okay. When is the light to the positive PR? When we expose the light to the positive PR, there's a light make a break their bond in chemical. So we third step is develop. Develop means in the develop level steps, there is a remove their PRs. We can see the remove the PR. And negative PR is strength and force. It's make a more stronger chemical bond so it can remain after the developed station. This is the difference of the two types of the PR. And we can make this shape, and we can, this is after the develop. Develop is, is moving and other situation happening. This step is removing, or this area is removing. Difference from dependent of the what type of the PR. And edge is a cut off there what we want to area. This curved area make it more shape deeper, and this is what we want to planning to our semiconductor. And fifth step is strip. Strip means remove our PR layers, so we can take it the shaped vapor, and this is the first step of the semiconductor. And when we exposure step, we expose our light through the reticle and photomask. Photomask and reticle is some blueprint of the our planning to semiconductor. So light through the reticle and shape their vapor. And it is so very precise, and it is so align key is mean we have to alignment precisely. Alignment is very important because the mask or reticle is mismatched. It make the light is mismatched. It ruin everything. So this is the what we're okay. This is the align key. Align key gives us the precise technology. It is working the reticle. There's a reticle have to make an alignment their lines because of the light through the reticle. It passes only and precisely. So it can help us to alignments of these mask. And we can see the photolithography. This is a photo, we can use a photo, and this process is lithography. So you can see the 8th step of these steps. This step is there's so many recipe, but this step should have to do recipe because this is the standard recipe. First, cleaning the vapor, and second, we coat with the photo PR, and we can remove the water, and this is because of the wet. This is soft baking, and before we exposure the light align the mask, and exposing, and we can patterning our semiconductor vapor, and developing is the removing PR, and hard bake is making more strong and making their chemical bond is much more stronger. And this is another PR, and photo is something other we don't want it. This is removing station. And this is the important to how we expose the light is first, second, third. This is the how we expose the light. And first is contacting printing and proximity and projection. The contacting and proximity is not much used these days because it has many damage and lower image resolution, and much above, its have to size should be smaller and nanoscale. It is nearly full station, so we can use the projection printing. Is it the condense our light, so it has no damage, and we can make it more smaller pattern in the semiconductor, but it had to expensive and bigger machine. And there is some problem of this technique. We have to use the one exposure make a one die. So we can move in this stage, and there's a much more we can make it dies. So we should have to these steps is stepper. Stepper is the moving stage much equipment. So, and secondly, we can use the stepper more advancedly, so we can use the scanner. It makes a lens problem. It removes and improves the lens problem, and also it have a stepping function in the equipment. Next is light technology, numerical aperture and depth of the focus. This is the important because we're using a light, and their focusing point and their depth of the focus is it energy. How energy influence the area means the same. So there's using NA and CD. NA means it's how long and how wide this relationship, and we we have to focus on the CD. CD means nearly we can make the draw in the picture. Then this lines the width is the CD. So smaller CD, we can make it more smaller conduction, a more smaller semiconductor. So this is important to reduce the CD value. So we can use the other factor, we can control it, but if we have some problem this controlling other section, then we can use this control this. This is so-called immersion litho. It make it worse than lens and vapor. Between we can fill this water or other material. It make much more and improve. So we can use, and it's grow and CD is just getting lower, and we can make it more smaller semiconductor. This is the CD SAM. It called the critical dimension scanning electronic microscope. This is what this make us this what we make it in the nano dimensions. It makes us to see what we make it. Okay, this time is over. Thank you.